Q5505, which maximum range factor decreases as weight decreases? A. Altitude. B. Airspeed. C. Angle of attack. The correct answer is B. The maximum range factor is a concept used to determine the optimal airspeed for achieving maximum range during flight. It represents the ratio of the true airspeed to the square root of the aircraft's lift-to-drag ratio. As weight decreases, the maximum range factor decreases as well. This is because with a lighter aircraft, the lift-to-drag ratio typically improves, allowing the aircraft to fly more efficiently at lower airspeeds. Therefore, to achieve maximum range, the airspeed needs to be reduced. Conversely, at higher weights, the aircraft typically has a lower lift-to-drag ratio, requiring a higher airspeed to achieve the best range performance. This is why as weight decreases, the maximum range factor decreases, indicating a lower optimal airspeed. Therefore, the correct answer is that the maximum range factor decreases as weight decreases, affecting the optimal airspeed. 5217. What performance is characteristic of flight at maximum lift/drag ratio in a propeller-driven airplane? Maximum. A. Gain in altitude over a given distance. B. Range and maximum distance glide. C. Coefficient of lift and minimum coefficient of drag. The correct answer is B. The maximum lift/drag ratio occurs at the angle of attack, where the lift generated by the wings is at its highest while the drag is at its lowest. This configuration allows the aircraft to achieve the greatest efficiency in terms of range. At this point, the aircraft can cover the maximum horizontal distance for a given amount of fuel or energy consumed. 5205. In small airplanes, normal recovery from spins may become difficult if the A. CG is too far rearward and rotation is around the longitudinal axis. B. CG is too far rearward and rotation is around the CG. C. Spin is entered before the stall is fully developed. The correct answer is B. Any airplane's ability to recover from a stall increases in difficulty as the center of gravity advances to the rear. This is crucial for spin recovery since any airplane will reach a point when loaded from the rear at which a flat spin will form. 5974. A swept-wing airplane with weak static directional stability and increased dihedral causes an increase in A. Mach-tuck tendency. B. Dutch roll tendency. C. Longitudinal stability. The correct answer is B. Dutch roll is an oscillatory motion of an aircraft characterized by alternating yawing and rolling motions. It is a common stability issue in swept-wing airplanes with weak static directional stability and increased dihedral. When an aircraft has weak static directional stability, it means that it has difficulty maintaining a coordinated flight and tends to yaw or deviate from its intended direction. Increased dihedral, which is an upward angle between the wings, can exacerbate this yawing tendency. The combination of weak static directional stability and increased dihedral creates an aerodynamic coupling that leads to an increased Dutch roll tendency. The yawing motion induces a rolling motion, and vice versa, resulting in an oscillation between yaw and roll. Therefore, in the given scenario, a swept-wing airplane with weak static directional stability and increased dihedral causes an increase in Dutch roll tendency. 5207. If an airplane is loaded to the rear of its CG range, it will tend to be unstable about its A. Vertical axis. B. Lateral axis. C. Longitudinal axis. The correct answer is B. When an airplane is loaded to the rear of its center of gravity, CG, range, it means that the center of gravity is positioned too far aft. This has a significant impact on the lateral stability of the aircraft. The lateral axis of an aircraft runs from wingtip to wingtip. Stability about the lateral axis refers to the aircraft's ability to maintain its roll attitude and resist rolling oscillations. When the CG is located too far aft, it shifts the balance of the aircraft, making it more prone to rolling moments. This can lead to a destabilizing effect, causing the aircraft to be unstable about its lateral axis. Therefore, if an airplane is loaded to the rear of its CG range, it will tend to be unstable about its lateral axis.